for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the strength of acids. In our last lesson, we learned about different ways to classify acids. We learned that they can be classified in terms of the number of ionizable hydrogen atoms they possess. We also learned that acids can be classified in terms of the number of constituent elements they have. In today's lesson, we will define strong and weak acids, and we will distinguish between the two. We will also define concentrated and dilute acids and discuss the conceptual difference between them. This lesson will also include a discussion on safety precautions that need to be taken when dealing with acids. Let us get started. Acids can be classified as either strong or weak, depending on their degree of ionization in aqueous solution. In other words, they can be classified by the extent to which they dissociate to form hydrogen or hydronium ions when they dissolve in water. A strong acid is one that ionizes completely in aqueous solution. For example, perchloric acid, hydroiodic acid, hydrobromic acid, hydrochloric acid, nitric acid, and sulfuric acid are all strong acids that dissociate to a high extent. When strong acids are diluted in aqueous solutions, they mostly contain ions derived from the acids rather than the acid molecules. Hydrochloric acid and nitric acid, for example, are almost completely ionized in water. An acid that releases few hydrogen ions in aqueous solution is a weak acid. The aqueous solutions of these acids contain hydronium ions, anions, and molecules of the acid that are not ionized. For example, organic acids that contain the acidic carboxyl group COOH are often weak acids. Acetic acid, as you can see here, ionizes slightly in water to produce hydronium ions and acetate ions. Acids are referred to as being either concentrated or dilute. This is dependent upon the relative amount of an acid that is within a solution. A concentrated acid contains a relatively large amount or percentage of acid and a small amount of water. For example, a concentrated solution of sulfuric acid contains 98% sulfuric acid and only 2% water. And a concentrated solution of acetic acid contains 99% acetic acid and only 1% water. The percentage discrepancy is due to the fact that sulfuric acid is quite strong, whereas acetic acid is weak. A dilute acid contains a relatively small amount of acid dissolved in a large amount of water. For example, a diluted sulfuric acid solution might be 10% sulfuric acid and 90% water. The concentration of an acid is the measure of the number of moles of the acid in 1 liter of acid solution. It is expressed in moles per liter, which is a unit of concentration known as molarity. As you can see here, molarity is denoted by the letter M. In order to determine the number of moles in a substance, we can simply divide the mass of a substance in grams by its molar mass. Let us discuss an example. We have a solution of 98% sulfuric acid, which has a concentration of about 18 moles per liter. If 1 liter of this solution is added to 2 liters of water, we then have 3 liters of solution. However, the concentration will decrease to 6 moles per liter. The new solution would be dilute rather than a concentrated solution of sulfuric acid. Therefore, concentrated acids have a greater number of moles of acid per liter than dilute acids. Students, let us do an activity. Please determine the number of moles of hydrochloric acid present in 2.3 liters of a 1.5 m hydrochloric acid solution.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure you had no trouble completing this activity. In order to determine the number of moles in the solution, we simply multiply the molarity by the volume of the solution. This gives us our answer, which is 3.45 moles of hydrochloric acid. If you answered that correctly, great work. As we learned in our last lesson, acids are electrolytes. This means they have the ability to conduct electricity in aqueous solutions. Aqueous solutions of strong acids are better able to conduct electricity than the same concentration of weak acids. This is because the ability to conduct electricity depends upon the amount of ions present in the solution. Finally, students, it is important that we discuss how to safely handle acids. Most concentrated acids are very corrosive and poisonous. They can destroy metal, clothing, or worse, human flesh. If swallowed, acids can even cause fatality. What kind of precautions should be taken when dealing with acids? Please discuss this question with your classmates and write down the ideas you come up with.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, everyone. I am sure you came up with some very important precautionary measures for dealing with acids. It is important to always wear goggles, gloves, and a laboratory coat when dealing with acids. Always use bellows to pipette acid rather than sucking it with your mouth. Dilute acids by adding the acid to water, not the other way around. If concentrated acid is spilled on cloth, immediately run it under water. If an acid spills on your body, it should immediately be flushed with water and then with 10% sodium carbonate. If acid enters your eye, flush it with water, then consult a doctor. If acid is accidentally swallowed, administer weak bases such as magnesium hydroxide or aluminium hydroxide. Today, we learned about strong and weak acids, as well as concentrated and dilute acids. We also discussed precautionary measures to take when working with acids. In our next lesson, we will learn about the pH scale. This brings us to the end of our lesson. Until next time, thank you, teacher. Thank you, students.